So let's look at an example involving the natural log function. So there's a whole section devoted to integrals that result in the natural log, but this is an integral that has natural log as part of the integrand. So let's say I have ln of x squared over x dx. And so I just want to rewrite this so that you're able to see. We can write this as ln of x squared times 1 over x dx. Now ln of x is inside my grouping symbol, so we'll let u equal ln of x. And then du, the derivative of ln of x, is 1 over x dx. And we can see that here's my u, so this is my du, and then we have u squared here. So our new integral then is u squared du, and that's 1/3 u cubed plus c. And then the last thing is we're going to substitute what u is, 1/3 ln of x to the third power plus c. So let's look at a trig expression. Let's say we have the integral of cosine x times sine cubed x dx. So in this case, I know that the derivative of, I know the derivative of sine is cosine. So I'm going to make my u equal to sine. Sine is also in the grouping symbol. You can think of this as sine x to the third power. So we'll let u equal sine x. Du is equal to cosine x dx. And then what we'll be integrating is u cubed du. And that will be equal to 1/4 u to the 4th plus c. Substitute back in sine x for u, and we have 1/4 sine to the 4th x plus c. So what you should notice from all these examples is once you've used your du, it goes away. That cosine x is no longer part of the integrand because you're replacing that with du, and now this is just saying integrate with respect to u. So you can have that type of problem involving a trig function, but you can also have an expression, say the integral of sine with something in the angle measurement. So let's say we're integrating sine of 2x plus 1 dx. So in this case, my inside function, my u, is going to be what is in the angle argument. So let's let u equal 2x plus 1. Du is equal to 2 dx. We don't have that 2 as part of our integrand, so we're going to divide everything by 2. That's 1/2 du is equal to dx. So I'm replacing this dx with 1/2 du. That 1/2 becomes a constant. I can just go right ahead and put it right out front. And then I'm going to integrate sine of u du. So the integral, the antiderivative of sine u is negative cosine. And so this is going to be negative 1/2 cosine of u plus c. Substitute back in the u will give us negative 1/2 cosine of 2x plus 1 plus c.